All right, let's jump right in. Think about all the apps you use every single day. For the most part, they just work, right? But what's the invisible stuff, the magic behind the scenes that keeps them from crashing or slowing to a crawl or becoming impossible to update? Well, today, we're going to talk about the three crucial pillars that hold up every great piece of software: reliability, scalability, and maintainability. You know, this quote from the computer scientist Alan Kay just nails it, doesn't it? We've come to expect technology to be this dependable, almost like a force of nature. You tap an icon and you just expect it to work instantly. But that smooth experience, well, it isn't natural at all. It's very, very carefully engineered. Because here's the reality. Behind that simple screen is an incredibly complex system. What feels like one app is actually this hidden dance between all these different parts: databases, caches, search indexes, you name it. They're all working together. And just keeping this whole symphony in tune is a massive, massive challenge. So yeah, how do engineers keep this whole complicated machine from just falling apart? Well, you don't just write a bunch of code and cross your fingers. You have to design the entire system around three core, absolutely non-negotiable principles. Let's break them down one by one. Okay, our first pillar is reliability. And the question it asks is actually pretty simple. Can we trust this thing to do its job, especially when the unexpected happens? Because, let me tell you, things will always go wrong. So what do we really mean by reliable in this world? It means the system keeps on working correctly. It does the thing you expect it to do at the speed you expect it to do it, even when it's facing some kind of adversity. Could be a hardware crash, could be a software bug, could be a human mistake. Now, this is a really crucial distinction we have to make. On one side, you have a fault. That's when one small piece of the system, maybe a single server, messes up. On the other side, you have a failure, and that's when the entire system stops working for you, the user. The goal of a reliable system isn't to prevent every single fault. That's just impossible. The real goal is to build a system that can tolerate those little faults without ever letting them cause a total failure. And trust me, these faults can come from literally anywhere. Hardware fails, disks trash in data centers all the time. Software has sneaky bugs that you don't find until it's too late. And of course, there's us, humans. We make mistakes. There's actually one study that found that human error was the #1 cause of outages for huge internet services. A truly reliable system has to be ready for all of it. This leads to this wild, kind of terrifying idea. How do you know your system can really handle faults? Well, you test it by breaking things on purpose. Companies like Netflix famously created a tool called the Chaos Monkey that just goes around and randomly shuts down parts of their live production system. By causing faults deliberately, they make sure their system is always ready for the real thing. It's brilliant, really. Let's move on. It's awesome if your system is reliable for a few thousand users. But what happens when it's 1 million or 100 million? This brings us to pillar number 2, scalability. This is all about having a plan for success. At its core, scalability is just about a system's ability to cope with an increased load. It means you've thought ahead. You have smart, reasonable ways to handle a huge spike in traffic or a massive increase in data without the whole thing just grinding to a halt. But you know, load isn't just one simple number. It's totally specific to what your app does. To make this really concrete, let's take a look at the scaling challenges at Twitter, which are all about this concept called fan-out. So Twitter's first approach was super straightforward. When you wanted to see your timeline, the system would find everyone you follow, pull all their recent tweets from the database, and merge them all together. Makes sense. But can you imagine the system doing that for millions of users at the same time? The database was getting absolutely hammered with all these read requests. It was a huge bottleneck. So they flipped the model completely. This is approach 2, the fan-out method. Now, when a user posts a tweet, the system does way more work up front. It immediately takes that tweet and delivers it into a personal timeline cache for every single one of their followers. This makes reading your timeline incredibly fast. But you see the trade-off, right? The workload is now on the write side. A single tweet from a celebrity could trigger millions and millions of write operations all at once. So once you have an architecture that can scale, how do you know if it's actually performing well? The single biggest mistake people make is to just look at the average response time. And let me tell you, the average can be a total lie. So why is looking at averages so bad? Because an average can hide really nasty problems. Look at this chart. Most of your users might be having a super fast experience, but a small handful of them are getting an incredibly slow one. The average time might look totally fine, but some people are having a terrible time. That's why engineers focus on percentiles.
They'll measure something like the 95th percentile, which tells them the experience that 95% of users are getting, or better. It forces them to pay attention to their unhappiest customers.
And this isn't just some abstract technical thing. It's a huge deal for the business. Amazon, famously, tracks the 99.9th percentile. Why? Because they found out that the users getting the slowest responses were often their best customers, the ones with these long, complicated purchase histories that took more data to process. So by focusing on the high percentiles, you're often making sure your most valuable users are happy.
And that brings us to our third and final pillar. This is the one that's all about playing the long game: maintainability. A system, no matter how clever, is only useful if human beings can actually continue to work on it and improve it.
This is just a hard truth of building software. The real cost isn't in building version 1. It's in the years and years of ongoing maintenance, the bug fixes, the security patches, adapting to new business needs, just keeping the lights on. A system that's hard to maintain is a ticking time bomb. Maintainability really boils down to 3 key ideas. First, operability. Is it easy for the operations team to keep this thing running smoothly? Second, simplicity. Can a new engineer join the team and actually understand how the system works without getting lost in a crazy maze of complexity? And third, evolvability. How easy is it to change the system and add new features down the line? So there you have it, the 3 pillars. You've got reliability, which makes sure the system keeps working even when parts of it break. You've got scalability, so it can handle success and growth without falling over. And you've got maintainability, which ensures that humans can actually manage and improve it for years to come. These principles are the invisible foundation of pretty much all the technology we rely on. So the next time you post a photo or stream a movie or just check your feed and it all works perfectly, just take a second. Think about the incredible, complex, and really thoughtful engineering that's making that simple moment possible. What invisible architecture are you relying on right now?